Hi guys, in this video what we're going to do is look at what's called expected value of a random variable. I'm just going to have a quick look at an experiment here where we're going to toss a coin 3 times, and you can see here that the outcomes aren't going to be numbers. We're going to get tails, 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 tail, tails, head, etc. We should be happy if we toss a coin 3 times that we're going to get 8 different outcomes because of the fundamental idea of counting. 2 times 2 times 2, so that's going to give us 8, and there's 1, 2, 3, 4, 5, 6, 7, 8 outcomes there, okay? Now what we can do is we can put this into a table, and we can say, right, okay, let x be the number of heads, is what we've decided to put our variable as here. So you can see here, if I just list them, it's my sample space here, I've got tails, 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 which means there's no heads. There's tails, tails, heads, tails, heads, tails, heads, tails, tails. That's when I get 1 head, and so on and so forth, guys. You can see here that there's a chance I can either get 0 heads, I can get 1 head, 2 heads, or 3 heads. And these are the associated probabilities here. So you can see here that tails, 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 no heads means that I've got a 1/8 chance of getting no heads. For 1 head, you can see there's 1, 2, 3 different outcomes. So that's 3/8. For 2 heads, you can see there are 3 different outcomes out of the 8. And for triple head, you can see here there's only 1 out of 8. Notice, guys, quite obviously that one of these things has to happen. Therefore, these probabilities here must sum to 1. If it doesn't sum to 1, you've made a mistake. And this is all it's saying here in this sentence here. It's saying we always get a total of 1. So P of 0 here plus P of 1 plus P of 2 plus P of 3. So that's probability of getting 0 heads plus probability of getting 1, probability of 2, probability of 3 is all equal to 1. And we can abbreviate this using what's called sigma notation. And all this means is that if we sum all the probabilities of x, where x is a member of this, we should get 1. So this is just another way of writing what we've got here. Okay, this is what we call sigma notation, and we're going to meet that later on in the course. Okay, so you can see I've just completely copied that across. You can see here this is the exact same table as before. What we can do is we can convert it into a sort of frequency table that you did in Junior Cert. So you can see here we're going to, again, you just have to define what the variable is. We've said that x is the number of heads. You've just got to remember that's what it is. So you can see here that for 0 number of heads, it's an 1/8, 1, 3/8, 2, 3/8, and 3, 1/8 as before. And this is just a frequency table. And what we're trying to work out is we're trying to work out what would be the average number of heads. So suppose I was going to keep doing this experiment over and over again. What would the average number of heads be for 3 tosses of a coin? So the way we do this is we take the x, our x value, and we multiply it by the probability associated with that x value. So here what you can get is you get 0 times 1/8, and then we add the next one plus 1 times 3/8 plus 2 times 3/8 plus 3 times 1/8, and then we have to divide it by the sum of all of these things here. Now notice that the probability of all the x's here is always going to be equal to 1, or it should be. So let's go and have a look. So mu, this again is another Greek letter. Mu means population mean, okay? And we call this the expectation of x, what we expect our value to be. And notice here, look, 0 times 1/8 plus 1 times 3/8 plus 2 times 3/8 plus 3 times 1/8. So you can see here, and we're dividing it by all of the probabilities added together, which is going to make 1. If we do that, you see we get 12 over 8, which is 3 over 2, which is 1.5. So what we're saying is if we toss 3 coins, we'd expect on average, and that's the important thing here, guys, on average to get 1.5 heads. Now I know we can't get 1.5 heads, but what we're saying is that on average that's what we'd expect to get. So we'd either get 1 or 2. We'll be more likely to get 1 or 2. We're not going to get 1.5 heads if we throw 3 coins in the air. It's not possible, but that's going to be the long-term average, i.e. the expectation of x, and we can work around that. It's a bit like when we talk, or you hear people talking about the fact that there's a family with 2.6 kids. I think we've had this discussion before, and it's just a case of it's 2.6, yeah, okay, we can't chop a child into 0.6, but it's an average, okay, and an average can take a decimal place. This slide is just saying exactly what I just said, but in the general form, rather than going in a specific form like we did before. So it's saying that we can have a certain amount of outcomes. This is, for example, the number of heads. So 0, 1, 2, 3, 4, however many we decide to toss the coin for. This is the associated probability of said number of heads or said event happening. Okay, and you can see what we did before. We said that our mu, our average, our expectation of x was equal to this, multiplied by this, plus this, multiplied by this, and so on and so forth. And then it was divided by all the probabilities, which would just normally sum to 1. And what we're now saying is that if we use the sigma notation, we can say all it is, it's the sum of all of the x values multiplied by the probability of that associated x value. Now guys, you are not going to be expected to prove this or to show this. You just have to be able to work out associated expectations of x's. So let's have a look at an example. So what we have here is Paul selects 2 cards at random and without replacement from a pack of cards. What's the expected number of hearts that he can get? Well, if he selects 2 cards and he's after hearts, there's only 3 things that can happen. He's either going to get 0 hearts, 1 heart, or 2 hearts. So there's your table for you. So if we let x equal the number of hearts he gets, so there we are, we now defined that variable. And we go down, I just do the table down here, we're going to do a little bit of work with it. So we've got x as here, and basically the probability of x is going to be underneath it. That's just all we have to do, boys, just make that table. And we get 0 hearts, 1 heart, and 2 hearts. And it's just a case now of working out the associated probabilities. And once we've done that, putting it through and just multiplying them together like we did on the previous slide. So let's work out the probabilities of 0 hearts, 1 hearts, and 2 hearts. Let's have a look at 0 first. So 0 hearts. Okay, so let's have a look here. Well, that shouldn't be too hard if we get, we know there's 13 hearts in a packet. Okay, or a pack of cards, not a packet. 13, choose 0. And we want the rest of them, 39, choose 2. And we'll get all over the total number of ways we can do that, which is 52, choose 2. Now that's one way of doing it, guys. The other way we can do it is just to say, well, it's 39 over 52, because it's 39 cards that aren't hearts, times 38 over 51. And those 2 ways will give you exactly the same answer. And if you work that out, boys, you're going to get probability of 19 over 34. Okay, so those 2 things will both give you 19 over 34. Okay, let's move on to the 1 heart. So the 1 heart. Okay, and again, using the combinations method, you can see we have 13, choose 1, because we want one of those hearts, which means that from the remaining 39, we want to choose another one. And that therefore is over 52, choose 2. We can whack that in our calculator and get the answer. Now for the other way of doing this, there's 2 different ways of doing this. So we could have 1 heart. So it's either going to be heart, not heart, or not heart, followed by a heart. So you've got to be aware that there's 2 different ways that we can do that. Now the great thing about the combinations way is that you don't have to think about this here. Okay, but if you don't use the combinations way, then you do have to think about it. This is going to give you, if we work out heart, not heart, you can see they're going to be exactly the same thing. We're going to have to multiply it by 2 at the end in order to get the correct answer. So what we have here is a heart, the first one, which is going to be 13 out of 52. Multiplied by a not heart. Now there's 39 of them in the pack, but remember we've lost one, so it's multiplied by 51. You can see that this is going to give you, so this here is just going to be this exact thing, but it's going to be the other way around, where we're going to get 39 over 52 multiplied by 13 over 51. So we can say it's just this one times by 2, or we can just put add if you want, and we'll have this one's going to be 39 over 52 multiplied by, and it's going to be 13 over 51. Notice that these 2 things are exactly the same, guys. There's 2 different ways that we can have 1 heart and not a heart. It's either heart, not heart, or heart, not heart, heart. Again, if we put them into your calculator, it doesn't matter which one you use, what we're going to do is we're going to get an answer of, I think it's 13 over 34. So 13 over 34 for this. And then we've got 2 hearts. Okay, 2 hearts again. So using the combination method, we get 13, choose 2, and we get 39, choose 0. All over 52, choose 2. Okay, because that's the total number of ways we can do it. Otherwise, we can say that if we want 2 hearts, then we've got a 13 over 52 chance, multiplied by, there's 12 left out of 51. And again, guys, you're going to get exactly the same answer. And the answer to this one is, when you work that out, is 1 over 17. Okay, so 1 over 17. You stick them in. I've already put the first one in, 19 over 34. The second one's 13 over 34. And the third one is, I'm just going to put it into 34th so we can just add them up very, very quickly. It's going to be 2 over 34. Okay, it's 1 over 17, 2 over 34. Add them together, guys. You get 19 plus 13, so that's 32. Plus the 2 is 34. 34 over 34, it comes out to be 1. So that means I've not made a mistake. Now, guys, make sure you double check that, because if you've done this and you hadn't, if you'd only done it one way, i.e. just done heads and not heads, you would have worked out you made a mistake somewhere, because this wouldn't have added up to 1. Okay, so just make sure that you do that. Now, what you can do, a lot of people like to do here, is just do x by p of x. So what they do is they create an extra row there and just work out what's going on here. So 0 times, so here we look, 0 times 19 over 34 is just 0. 1 times 13 over 34 is just 13 over 34. And then 2 times 2 over 34 is 4 over 34. Just to go through that again. So 0 times this gives me this. 1 times this gives me this. And 2 times this gives me this. Okay, we're trying to do the expectation of x. So all we do here, guys, if we set up as a table, is all we have to do is put an extra column in and work out the sigma of x by p of x. Okay, so all we're doing is we're just adding this to this to this, whatever that happens to be. So let's do that in our heads now. So 13 plus 4 is 17 over 34, and that will work out to be, we can simplify that to be equal to a half. So the expectation of x is equal to half of a heart. So what we're saying is that if we select 2 cards at random without replacement from a pack of cards, we'd expect, on average, I know we can't get exactly half a heart, on average we'd expect to have half a heart. So that's it. That's expectation of x.